I will show you how I use Excel to solve this problem. It's a mass moment of inertia problem, but that could be, you could use this method for moment of inertia of an area too. It's not just to find the centroid. Okay, so what we try to find is the moment of inertia about an axis perpendicular to my screen, normal to my screen, and going around 0. Okay, so an axis there. So what I will do first, I made a table already. I put the 3 different shapes, rod, plate, and disc. So purple, blue, and green. And I will list the mass of each of them. So the mass of the rod is 0.2. The mass of the plate is 1. And the mass of the disc is 0.5. I will add the dimensions that I need to find their mass moment of inertia. So this, it depends of, so I will have the axis about the centroid of the plate, the axis about the centroid of the rod, and the axis at the mass moment of inertia about the centroid of the disk. So if I look at my formula on the right, I will have the disk about z, this one. So that's this one. I will need the radius about z for the plate. That will be this one. And for the slender rod, that will be the I-ax or IY, one of them. That will be this one. So I will add the data that I need. For the rod, I need the length of the rod. The length of the rod is 1. I found it there. Okay. For the plate, I need 2 distance. I need A and B. That's why I put A and a B column. That will just be for the plate. I need A and A square plus B square, as we can see on the right. So the A, it doesn't matter which one is which one, but let's say the A is 0.3 and 0.5 for B. And for the disk, what I need for the disk, if I look there, the mass and the radius I have radius there 0.4. Oops, 0.4. Now I will find the mass moment of inertia for the centroid of each of them. So for the rod at G, that's 1/12 of ml square. So I wrote equal 1 divided by 12 time ml square. So m, that's my mass, time my L square. That's my MMI. It will be in kilogram time meter square. For the plate, it's equal to, so equal, open parentheses, 1/12, close parentheses, time the mass of the plate, time, open parentheses, A square plus B square. Enter. My mass moment of inertia about the centroid of the plate. And the disk is 1/2 of mr squared, so it's equal to 1 divided by 2 time the mass of the disk time the length, the radius square. So I have the mass moment of inertia of each of them. Now for the theorem of parallel axes. Remember the theorem of parallel axes? There will be O equal to I at the centroid, or CDG, or the center of gravity, plus the distance square time the mass. And this distance is between O and C. Okay, that will be different for each of them. So for the rod, we already have the value at the centroid, so the distance is 0. For the plate, the distance will be this one, between this one and this one. So that will be, and don't make the calculation in your head, just like type a formula. It will be equal to what? It will be equal to the L divided by 2, so the L of the rod, this one, divided by 2, plus the 0.3, so this one, divided by 2. That's the distance from the centroid. And for this, the disk, you see it's a little bit different. That's just the L divided by 2. Okay, because the disk is centered on the rod. It's like on the top of the rod. So the distance will just be equal to L of the rod divided by 2. Here we go. And now the mass moment of inertia, it's equal to what? It's equal to equal mass moment of inertia of each shape at their centroid plus the distance. Let's do plus the mass first. So moment of inertia about the centroid plus the mass time the distance that you found square. Enter. And because the formula is exactly the same for all of them, what you can do, you can just click on G4 and drag it with a little square. and we will have the mass moment of inertia, if you look at the formula, using those data for the plate and the mass moment of inertia of the disk, and now we are using the data for the disk. The total mass of inertia will be equal to the sum of all of them. Be careful if you have something negative, you did both negative and positive. So this is the total mass moment of inertia. It will be in kilogram times meter square. I like to write my units close, and maybe I can write it that it's the total MMI. So I know. Oops. So that's how I solve most of the problem. And as you know, I love to have some variables. So if I change just the value of the road, now it's 0.4, that will change the value, the other value. And now it's 0.2, that will change data. The length of the road, if I change it to 0.8, that will change all my data, because I will also change the distance from the centroid of each of them. Let's go back to 1. So there we go. That's my little system to solve a problem, a statics problem using Excel. And in this example, that was for the mass moment of inertia. Hope it helps. Bye-bye.